So we're going way back to first semester, like first week of school. So how do you know if a limit exists if what two things are equal?
The left and the right.
Okay, good. So the limit as x approaches c from the left has to equal the limit as x approaches c from the right. So remember, you only have a limit if your left and your rights are the same. Okay, so you have a little lovely graph here. So if I want the limit as x approaches -2 with a minus, remember that means from the left. So if I'm looking at 2 right here, and I'm tracing it from the left, what y value? Oh, pretend 1, 2, okay? What y value would that be approaching? 2. What about if I approach from the right side? 1.
Helen, you already took it.
Okay?
You already done this?
No, I didn't do this part with them. And then for c, what would it be if I want the limit for 2 then?
Yeah, it really was.
Good, D and E is correct. Good job, Nani. Okay, because remember, if your left and right limits aren't the same, you don't have a limit as you go to that number.
Also, never mind.
Okay. Limit 5 from the left. Okay, that's supposed to be a little arrow on the end. If your graph just keeps going up forever, does it have a limit?
No.
D and E. Okay, so anytime that you're approaching an asymptote, that would be D and E, or any function that doesn't stop at a certain value. Okay, look at 0 from the right. As I approach 0 from the right side, what y value am I approaching? 1. Okay, now this is a little bit tricky. We didn't really cover this very well back in the fall. If I want to approach 0, and I only have a right side, it would be D and E. And the reason why is because I have a right side limit, but do I have a left side limit? No. So if it's an end point, you're going to have that one-sided limit, but your overall limit is going to not exist because the limit as x approaches 0 from the left does not exist. Okay? So your limit as you approach 0 from the left doesn't exist. That makes the whole thing not exist if it's an endpoint. Okay? So go down to the next set of graphs. We're going to do some composites. Whenever you do a composite function, remember you're always going to start with the center function. So look at the first one. If I want the limit as x approaches 1 of f of x cubed, just focus on f of x. For my f of x graph, as I approach 1, okay, 1 is here, it would be the y value, which is 2. And then I would take 2 and cube it after. So start in the center, my limit is 2, 2 cubed is 8. Did everybody sign in already? Okay. Alright, go to letter B. Okay, I'm taking my x approaching 3, I'm going to apply it to f of x. So f of x as I approach 3, what is my, wait, is that a whole number? 3. Make it g so that it works out better. Pretend that's a g of x. Okay, g of x, as I approach 3, what's my y value? 0. And then I would take my 0 and I would find the cosine of 0, which is 1. Okay, next one. I want the sine of f of x as x approaches -1. Well, what is f doing at -1?
Wow. 0.
It's 0, and what's the sine of 0?
And the phi. 0.
0. Because remember, you can take the sine of 0, right? Okay, so now do that bottom one. Give it a shot. You want the graphs of f and g are shown above. The value of the limit as x approaches 1 of f of g of x. Where do you start? With the graph of f or the graph of g?
The g of 1.
Okay, so start at g first. And remember, you're looking for the limit. So if I'm looking at graph g, okay, which is right here, as I approach 1 from the left and the right, what y value is the graph approaching? 2. Good. Not 1. Okay, because remember, a limit is as you approach that value, what you're getting closer to. So it would be 2. And then I would take 2 and then apply it to the graph of f. In graph f, when my x is 2, what is my y value?
Non-existent because it's a cusp.
Oh, that would be the slope. But if we're just finding the y value, you can still find it. So it'd be 3. Okay? The trick answer there, though, would be non-existent, because you would see that hole and be like, oh no. But remember, not a problem for limits if there's a hole. Okay? Turn the page. Alright, next thing that we need to talk about is asymptotes. Okay, I'm going to give you the definition of an asymptote. It should be on your cheat sheet. Remember, it's the limit as x approaches infinity of a function, and it has to equal L. The other option is that, remember, you can have limits to infinity. You can also have limits to negative infinity. So it does not matter which of those you're approaching, infinity or negative infinity. If it equals a number, it's one of your asymptotes. And also remember, you can have different asymptotes depending on which infinity you're approaching. Okay? So your rules for this would be Bobo, Bo2, EPF. There's another one that's Bobo, Botan, and Betsy or something. That's fine. Whatever you use is fine. But like, look at the first one. X is approaching what?
Negative infinity.
That means you're using your rules. It doesn't matter that it's negative infinity. It's one of the two infinities, so you're using your rules. Which one's bigger, the power on top or the power on bottom?
Power on top.
Okay, x squared is bigger. That means that it is which one? Undefined or DNE if it's a limit.
You want to straight DNE?
Yeah, if it's a limit, put DNE. But your answer for the asymptote question would be there's not one, right? Okay, so look at B. X is approaching infinity. Who's bigger?
E to the x.
Yep. E to the x exponentials are bigger than x plus 3, so that would be what?
DNE.
DNE. Okay, then on C, I don't know if you guys remember this, but if x is approaching negative infinity, and you're plugging that into an exponential function, what happens is you have e to the negative infinity, and whenever an exponential has a negative, you can move that term down into the denominator. Do y'all remember talking about that? Okay, and so if my e term ends up down here, now who's bigger, top or bottom? Bigger on bottom, so it would be, good job, 0. Okay? Alright, give D a shot. Now notice, D is all factored up, but you can still do it. You're going to have to times it out, and then use your rules. Sure. Constants would be the smallest, then logs, then powers, then exponentials. And then remember, the difference between a power and an exponential is that a power is like x squared, an exponential is like 2 to the x. So it depends whether the variable is the base, that makes it a power, or if the variable is the exponent, that makes it exponential. No. Okay, so look at D. What is the power on top? Even though it's not timesed out for you, multiply just the two x terms together.
X squared on top and bottom.
Okay, x squared on top. What about on bottom? X squared. That means it's equal power. Okay, here's where you have to be careful. What is the top biggest term when you times these two together? Negative 2x squared. And remember that that negative is going to matter. What is the biggest term on the bottom? 1x squared, right? So when I pick these numbers in the front, what's my ratio? Negative 2, yeah. And so the trick answer there would be 2. If you miss this negative here, you'd end up getting the question wrong, okay? Alright, other ways to evaluate limits. So what we just did are infinite limits, because you're going to infinity. If you're going to a number, these are all the different ways that we talked about how to evaluate them. The first one's direct substitution, plug it in. Okay, remember you can also factor cancel. If it cancels, it's going to create a hole in the graph. But remember that if you have a hole, your limit still exists. That means that your values still approach that empty spot where that hole is. Okay, and then if it's in the denominator and it does not cancel, what does that create? Do y'all remember? An asymptote. Very good. Asymptote. And remember, at an asymptote, what did we say about the limit? It does... Hi, Josh. It's okay. Grab that sheet as you come in, that packet. Okay, and then remember both asymptotes and wholes are considered discontinuous. Okay, one of them has a limit, the other one doesn't, but they both are not continuous because they have issues.
Do you mean both asymptotes or just one? Like vertical?
Only vertical, yeah, if you want to put a V there. I just couldn't squeeze it in. Okay, so let's look at a couple of these and then we'll come back to L'Hopital's rule. Number 1, can I plug in 3 or do I have to fix something? I can plug in 3. What's 3 squared? 9 plus 7. What's 3 plus 1 on bottom? 4. 9 plus 7 is 16 over 4, which is 4. And that would be your answer. Okay, look at the second one. Can I plug in 2 right now?
No.
Look at the bottom. If I plug in a 2 there, it's going to get all messed up. So we're going to try factor cancel. Okay, how can the top of that factor? X plus 2, x minus 2. X minus 2 on the bottom. And then when I look at that, those x minus 2's are going to cross out. And remember, that's good for us because if x is approaching 2, now I can go back to direct substitution. Plug that 2 in here. What is 2 plus 2? 4. Okay, go down to number 3. Look at it. Can I plug in 2 right now? If I factor cancel, would it solve the problem?
No.
What would happen when I factor the top of that?
No, it doesn't work.
It'd be plus and minus 3, and that's not going to cross out with your 2. In that case, if the issue is not fixable, it does not exist. Okay? Next one, look at it. We want to plug in pi. Can I plug in pi on the bottom? Yeah. I'd have the sine of 2 pi over 4 pi. Which angle is 2 pi the same as?
0.
0. And what's the sine of 0? 0. So remember, it's okay for you to get 0 on the top. Where you can't get 0 is on the bottom that you have to try to fix it. Okay? Next one. Actually, the next 2 we're going to need to do L'Hopital's rule. So come back up right here. Okay, L'Hopital's rule says if you're trying to take the limit of a fraction, you're going to take the limit of f prime over g prime. And we only spent like half of one day on this, so it's pretty easy, but basically L'Hopital's rule says you can still evaluate the limit, but you're going to take the derivative on top and on bottom and then plug it in. Okay, so this is what I mean by that. Let's do number 6 first. Okay, first question, look at number 6 here. Can I plug in 2 right now? If you, by some terrible, I don't know, disease, remember the difference of cubes formula, you could factor cancel that, but probably you don't. I don't know it either. So L'Hopital's rule is going to make it really easy. Take the derivative of the top. What do you get?
3x squared.
Okay. Take the derivative of the bottom.
1.
1. Now can I plug in 2?
Yeah.
Yeah. What's 2 squared?
4.
Times 3 is?
12 over 1.
Okay. So you're allowed to use, I'm going to put L'H, that's L'Hopital's rule. Okay, you can take those derivatives and it makes it easy. Okay, look back at number 5. Can I, infinity means we're using our rules, right? So which one's bigger, sine or 4x?
No.
What does sine x do? It goes 1, negative 1. 1,
4x.
negative 1. 4x is going to be bigger. Okay, so let's go ahead and add into our little list we made here. Sine and cosine both count as constants because they never get bigger than 1 or negative 1. So those are the same as just a normal number. So if I was comparing those, that would be 4x is bigger, which means it goes to what? 0. That's a bobo. Bigger on bottom goes to 0.
Can you go back up to the, what's it called?
Where is Nani?
She has this bean bag,
Coming from.
her thinking bean bag.
Into the list of, yeah, keep going up.
Okay.
A little bit more right there.
Right there. Okay, now with that one that we just did, number 5, you could also do it by L'Hopital's rule. What would the derivative, actually no you couldn't since it's infinity. Never mind.
Well, why would it be 0 again?
Because it's sine, which counts as a constant, and on bottom it's 4x, that counts as a power. And so powers are categorized as bigger than sine and cosine. So your bottom function's bigger, okay? All right, turn the page. Okay, next one. We want x to approach 1. Can we plug it in, or are we going to have a problem?
We have to do L'Hopital's.
Okay, we might have to do L'Hopital's rule, but remember, you only really need to do L'Hopital's rule if there's a problem. Can I plug in 1 into this without getting 0 on the bottom?
Yeah.
Yeah. So I'm just going to plug in 1 here and here. What would I get on the top?
E to the 3.
What would I get on the bottom? ln of 1 plus 3.
Ln to the 4th. Or 4th.
What is the ln of 1?
0.
It is 0. Okay, here's how you know. Listen, this is what my pre-cal teacher used to always say, and it was so annoying, but I say it like exactly like him. ln of 1 is the exponent you put on e to turn it into a 1. So if I want to get the exponent that I would have to put on e, I'd have to make it e to the 0 so that it turns into a 1. Okay, so that's a 0. Like over and over again. But I also had a crush on him, and he worked out at my gym. So it's totally fine. Okay, so ln of 1 is just going to be 0. 0 plus 3 on bottom is a 3, which means it would be what? B. Okay, now look at the next one. Can I plug in e there?
Yeah, because when the E cancel. No, you can't because.
What's going to happen on the bottom?
0 bottom.
E minus e, can't do that. So you have two choices. You can factor cancel, not going to work, or you can L'Hopital's rule it. Yup.
Yeah.
Okay, so we need to take the derivative. What's the derivative of ln x on top? 1 over x. And what about the minus 1? Derivative goes away, right? Okay, over, what's the derivative of x on the bottom? 1. So that's basically not even there. And then what are we plugging in?
Minus E.
We're just plugging in normal e, right? Because the derivative of this would be 1. So it'd be 1 over x on top, 1 on bottom, then I plug in my e, what do I get?
1 over 1
Wait, I
over
thought
1.
the derivative of E was still E.
Yeah.
The e is a number. E is a number. What's the derivative of a constant?
Nothing.
You're thinking of e to the x, the derivative is e to the x again, yeah?
Wait, so ln of e equals
That
1?
thing.
Yep. Because it'd be the exponent you place on e to make it stay in e. Mr. Taylor!
Doesn't help with my messing brain.
Okay, that's okay. So you get to here, then you plug in your e, you get 1 over e, which is?
Oh my god.
Is there an easier way to define what you were saying?
Okay, yes, let's do this. Okay, ready? You're wondering, what is the ln of e? Well, I'm going to let it equal x. Let's just say x we don't know, right? What is it? Okay, then do your little log loop. E to the x equals e. Well, then what exponent would you put on e to make it stay in e? 1. Okay, ready? Let's do this one now. ln of 1 is some crap that I don't know, yeah?
Yeah.
Okay, well, what's the base of an ln? E, right? So it'd be e to the x turns into a
E to the
1. Well, what exponent would I have to put on e to make it a 1?
0.
0, and that's how we know it's a 0.
What happens to the 1 over x?
Why? Okay, this is one of the other things you should learn in pre-cal, since you guys were sassing. Okay, that you didn't learn anything.
Wait,
That's why we don't know. 'Cause we
Now do you know? Okay, so ready? Pop quiz. What is the ln of e cubed?
What?
She really cried.
What exponent would you put on e to make it an e cubed?
3.
Boom, 3.
Good job, Maddie.
Thanks.
Yes, it would be a 3,
Cool
okay?
like that, man.
Ew, you just ruined
Wait,
the both.
what happened to the 1 over x? Why did you get 1 over e?
Okay, I plugged in e.
I really want to know what your teacher looked like.
Really? Do you have him on Facebook?
He played guitar, y'all. We can't get off. Okay, moving along. If you want more help on that one, I will help you more with it after,
Nah.
okay?
I don't care.
Okay. Look at the next one. Okay, we want to plug in 0. Can we do it right now?
No.
But can we do L'Hopital's rule?
Yes.
Okay, so take the derivative on top. What's the derivative of f of x?
It's
F prime of X.
Okay, we're going to take the derivative in a second. I'm just going to put f prime for now. Now, f of 0 is a constant, yeah? What's the derivative of a constant?
nothing.
0 goes away over what?
2x.
2x. Now, if I plug in 0 now, is that okay?
No.
Still no. You're going to get a 0 on the bottom. Do L'Hopital's rule again. What's the derivative on top? F double prime. And what's the derivative on bottom?
Wait,
2.
why are you taking the derivative again?
Because I still can't plug in 0 because there's still an x on the bottom. But if I do it one more time, now when I plug in my x approaching 0, is my bottom going to be a problem if it's just a 2? No. Now, f double prime we're going to have to get from right here. If that's f, what is f prime?
4x.
F prime would have been 4x. What would f double prime be? 4. So it would be 4 over 2, which is 2. Okay, but your trick answer there would be that it doesn't exist because you can't factor cancel. But remember, L'Hopital's rule can also be used to fix stuff. Okay? Alright, other thing we're going to talk about is continuity and differentiability. First thing for continuity, you have to be able to plug in A. Okay, you have to be able to plug in the number that you're talking about. Second thing is that your limit from the left
Equals limit.
and your limit from the right have to be the same. Now, you can check these in any order, okay, but those limits have to come out to be equal. If they are, then you have the limit as x approaches a, and that needs to be the same as whatever y value you got in step 1. So basically, you find the y value, find the limit, and then make sure that they're the same. Okay? Differentiability, f has to be continuous. Okay, which we're just going to arrow back all of this stuff. You would make sure that you have a y value, a limit, and that they're the same. And then you would want to make sure that the limits of f prime are equal to each other on either side. So your limit of f prime from the right has to equal your limit of f prime from the left. And then you have a little blurb here. Remember, if it's a graph, cusps, corners, and asymptotes all are not differentiable. Okay? So look at your next piecewise function. This is usually where you'll see questions about this. Look at the top part. Can I plug in 2 as the top and the bottom? Where would I plug in 2? Would I plug it into the top or to the bottom? Okay, why the bottom?
We can't equal 2.
Because this is where x is not 2, right? When x is 2, what's the y value? 1. So I'm going to do my little 3 steps here. Step number 1, f of 2 is 1, because it told me, check right here, that when 2 is the x value, 1 is the answer. Okay, now for number 2, I need to find my limit. So look at your thing. If I want the limit as x approaches 2, what is the problem with that?
Well, the first top one uses the top, right?
Well, if I plug in 2, what's going to happen on the bottom? 0, that's not going to work. So we're going to have to fix it. But how do we fix it? Factor. So factor the top, it'd be what?
Plus and minus.
Plus 2 and minus 2. And then what's going to cross out? Minus 2's now. Can I plug in 2? Yeah. Plug in 2, what are you going to get? 4. So down here I got a 1, up here I got a 4. Is it going to be continuous? No. Your limit as x approaches 2 of f of x is 4. So your y value is 1.
Would that be 2 to the left?
Let's talk about that in 1 second. Okay, so my y value is 1, my limit is 4. So, do I have a limit at 2? Yes.
But not.
Is it continuous? No. And if it's not continuous, can it be differentiable? No. So it would be 1 only, which is A. Okay, now, Sumaya asked a really good question. She said, well, wait, isn't that the left limit? look at the way, normally it'd be x less than 2 and then x greater than 2. But if this is everywhere x isn't 2, this is both the left and the right limit. Like if I were to graph this, this is what it would look like. It'd be like at 2, your y value is what, 4? So it'd be like blah, 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 and then randomly a 1. So when x is not 2, I'm using this top, both from the left and from the right. But at that one certain point, your y value is a 1. Okay, and this is a tricky way for them to set it up where it's not less than and greater than 2. That's everything that's not 2. Okay? Does that answer your question? Okay, turn the page. Next one, though, is not so tricky. Okay, look at it. We want to find the limit from the left and the limit from the right. We want to see if they're equal to each other. What are you going to do for that?
You would solve for it.
Well, you would plug in 2 on the top, then plug in 2 on the bottom. So let's plug in 2 up here. If I plug in 2 to that, I get, I'm going to be really specific here since we're reviewing for the AP test. This would be 2 to the left, right? It would be the ln of 4, and then I'm going to plug this 2 in. So what's 4 times 2? 8 minus 7. What's 8 minus 7?
1.
ln of 1. And do y'all remember what that came out to be earlier? 0.
I'm about to say 8.
Okay, limit as x approaches 2 now from the right. Where are we plugging in, top or bottom? Bottom. So plug in, okay, plug in 2 on the bottom. 2 times 4 is 8. 8 minus 7 is 1. Are those the same?
No.
Then is the number 1 thing correct?
No.
No. I'm going to put an X there. Okay, now the second thing is I need to check the limits of the derivatives. Okay, so in case you don't remember, I'm going to write it down here. The derivative of ln u is 1 over u times u prime. But if you look on your cheat sheet, it says or. You can do u prime over u and just make it one big fraction. This is the one that I'm going to use. Okay, because I don't want to have a fraction and then something else separate. So, if I want to take the derivative of that, this is my u. What would u prime of that be?
Of the top?
Of 4x minus 7 inside the ln.
4.
4 over 4x minus 7. Where this is my u prime, this is my derivative in the middle, and this is my original in the middle. Okay, that's my limit as x approaches 2 from the left of f prime of x. What about from the right? What's the derivative? What's the derivative of 4x minus 7?
Just 4.
Just 4. And if I plug in 2, are those sides going to come out to be the same? Think about it for a second before you answer so everybody can think about it. I'm going to plug in 2 right here. What's 4 times 2 on the bottom? 8 minus 7 is 4 over 1 equal to 4? Yes. So are my derivatives the same from both sides? Yes. Now, question. Just because your derivatives are the same from both sides, does that also mean it's differentiable?
No.
No. Why is it not differentiable?
Not continuous.
Because it's not continuous. Okay, so differentiable would not be true. Bye. So it would be which answer?
The C.
2 only, which would be that one. Okay? Alright, I think we have maybe a couple left, and then the last set of questions I'm going to give you the answers for, and you're just going to work on them till 5, which is in a few minutes. So, next section, we want to make it differentiable at 2. What has to be true about this and this for it to be differentiable?
Continuous first.
Okay, it has to be continuous. That means these sides have to be what?
Equal.
Okay, equal. So x plus 2b needs to be equal to ax squared. Now, if it's continuous, where do they have to be the same? Not for every x, only for the break point, which is 2. So I'm going to go ahead and plug in 2 as well. So I'm going to have 2 plus 2b. What am I going to get on the other side when I plug in a 2 here? 4a, yeah. Because the 2 squared gives you the 4. And then when I get to there, notice you have 2 sets of letters. So let's stop for a second. We want it to be continuous and what? Differentiable means what else has to be the same? Not just the sides, but their derivatives. Very good. So for differentiable, what is the derivative of the top? X plus 2b. What's 1? Why is the derivative of 2b going to go away? Because remember, b is a constant. So when you take the derivative of a constant, it's gone. It's 0. Okay, what's the derivative of the bottom?
2x.
The 2 will move down in front. Does the a stay there, though?
No.
Yeah, because it'd be like 2a is the constant, and then x used to be squared, now it's x to the 1.
So
And
why
then-
would you take the 2 from...
Do you notice that here the constant a is in front of x? It's like a coefficient, versus here the constant's by itself. That's the difference. Okay, and then from there, where do those derivatives have to be the same at x equals 2? So that means that really on this side, if that's a 2, that's a 4a, and a has to be what? 1/4. Okay, look at your answers. That pretty much eliminates D and E. If A is a 4th, can I take that back over here and find what B would have to be? What value would have to be there? What is a 4th times 4?
1.
So 2 plus 2B is 1. What would I do next?
1 minus the 2.
Okay, what is 1 minus 2? 2B is negative 1. Then what? Divide by 2. So it would have to be negative 1/2, which is which one? It would have to be A. So remember, you set the left and rights equal for continuous, you set the left and right derivatives equal for differentiable. Okay, last new thing we're going to talk about is the definition of a derivative. Okay, I'm going to remind you of what that is from like the 5th week of school. Okay, limit as h approaches 0 of f of x plus h minus f of x over h. This is the definition of a derivative. All that you have to do is recognize it, circle the function, and then take the derivative. So for example, if I'm looking at this big long question right here on the AP test, all that you have to do is say, oh, they want me to take the derivative. Derivative of what? F of x. Where is f of x on the top? Is it the first thing or the second thing? Okay, so this is what I want my function to be, and then I'm just going to take the derivative of that. So if it's sine 2x, what's the derivative of sine? Cosine 2x. And then what's the derivative of 2x in the middle for chain rule? Times by 2. So you're going to find the function in the middle. This is f of x. And then you're going to find f prime of x. Okay, those would be your steps if it's one of those. Okay? So look at the second one. Circle your function. It's your big, long definition. What's the function, Nani? ln x. And then what do I have to do with ln x? Find the derivative. What's the derivative of ln x? 1 over x. Yep. Good. All right. What time are we at? 4:57. Let's just do part A. We still have 3 minutes, and then I'll give you the answers for the questions at the back if you want to check. Okay, equation of a tangent line. What 2 things do you need? Okay, point and a slope. The point is going to be at the x value given. Will I plug in to the top part of the piecewise or the bottom part of the piecewise if x is 1? The bottom. So it'll be 1 comma, and then I'm going to plug in 1 to the bottom because that's a greater than 0. Plug into the bottom. And what will I get when I plug in 1 here? E to the negative 4. Very good. What else do we need? Slope. Okay, and your slope there would be the derivative of the bottom. What is the derivative of e to the negative 4x?
E to the negative 4x.
Times
4.
negative 4. Because remember, you got to use chain rule on that, right? Remember, that's your chain rule where you multiply by the derivative of the exponent. And then what are we plugging in? What's my x value? 1.
1.
So it'd be e to the negative 4 times negative 4. And then what do I do with these two things? Write my tangent line, yeah. Because we have our slope now too.
Why did you on the slope do e to negative instead of negative 4x?
Because I'm plugging in 1.
Okay.
Yeah?
That's why you take the slope because of the bottom because it's 1.
Say what you just said again.
You plug it into the bottom to find the slope because it's
Uh-huh.
greater than.
Because 1 is considered greater than 0. That's why you would use the bottom, correct? Okay? And then for B and C, if you decide to check it, it is continuous and differentiable. If you plugged in 0 on top and on bottom, it should not be differentiable. Okay? But you can check those. All right. I will send out the answers for 1 through 10. Or actually, do you guys have them since I checked yours earlier? Okay, what was number? Y'all just mark them, maybe like somewhere secretly, and then just check them at the end. Okay, number 1 to the side, somewhere hide it. What was number 1?
B.
D. Number 2?
B.
B. Number 3?
B.
B. Number 4?
B.
B. Turn the page. Number 5, what should it have been?
D.
D. Number 6?
E.
E. Number 7?
A.
A. Number 8?
B.
B. Number 9?
E.
E. Number 10?
E.
E. So those last ones are for you to try, check your work. If you're just here for the signature, you got it.
What were the first four?
I have
It was like something BBB. So DBB.
You're welcome.
Thanks, Nani. Okay, so then you're going to bring me your purple sheet, and I'm going to sign your top one.
5D.
And if you want to stay and work on it now, you totally can. Good job. Good job, girl. I don't know how you see from the floor. Don't forget to put your name on it so it doesn't get lost.
Oh, yeah.
Do you do 2 ends in the middle or just one?
It's just one.
This is for you.
Thanks.
I would like it back, please.
Okay, then I'm going to just give it back to you and give it to me in class tomorrow.
Okay.
Don't throw it away. There you go. Good job. Don't forget to put your name on it. How was Miss McDaniel's class? They make you do anything? No.
Who's in Miss McDaniel class?
Oh, you need a purple one. Get a purple one.
I need a purple one.
Yeah, this has some dates on it that are wrong.
How did you take the derivative of negative 2x?
Okay, what's the derivative of 1?
Nothing.
Hold on, ask me your question again, because I don't know if I'm answering it. What was your question?
How did you take the negative of negative 2 sin x?
What's the derivative of sine? Oh, will you give that to Marianne? What's the derivative of 1?
Nothing.
Okay, what's the derivative of sine x?
Cosine.
And so then you just keep the negative 2 in the front. So it'd just be negative 2 cosine x. There you go. What'd you say? You missed coming to this class so much today? You wish you had more math?
No, definitely not. What she said.
Just say yes, Monica. Yes, that is what I just said.